In the HPLC method development, selection of the stationary phase, that is selection of the column, selection of the mobile phase, selection of the concentration, selection of the method parameters play the crucial role. Welcome to this video, and in this video we are going to understand regarding the column selection for the HPLC. So when you can say that you have selected the right column. Column contains the stationary phase and it directly affects the method performance. So you can say that the column is a stationary phase and it is the heart of the HPLC system which controls the selectivity, efficiency, resolution of the HPLC method. So if you want proper results, your column selection should be proper and it should be right. So proper selection ensures accurate and reproducible results, better peak shape, shorter runtimes, improved sensitivity. The right column enhances the method robustness and overall performance of your analytical method. The selection of the HPLC column starts in the initial development stages, and if you select the right column, then you can develop a robust and specific selective method. You should understand regarding the columns. So first understanding should be regarding the column dimensions, then what it contains, that is what type of stationary phase it contains, how it is related to your method and your analytes. So length and internal diameter directly affect the speed, resolution and the sensitivity. Shorter columns will give you faster analysis with reduced solvent use. Longer columns will give you higher resolution, better separation. Narrow ID columns will give you higher sensitivity and will require lower sample volume because these are narrow. Wider ID columns suitable for the high flow and high load applications. So optimizing the dimensions means you are optimizing the efficiency and you are saving your time and cost. So optimizing dimensions means higher efficiency plus cost saving over the time. Particle size of the stationary phase. Typical particle size of the columns is like from 3 to 10 micron. Preparative columns have up to 75 microns. Smaller particles will give you higher efficiency, better resolution and reduced bond broadening. Then trade off higher back pressure will be there. Always match particle size with the system pressure limits, whether you are using it for the HPLC or UPLC. Then pore size. So it determines the interaction of the analyte. It determines how analyte interact with the stationary phase. Small pores ideal for molecules with less than 2000 Dalton molecular weight. Large pores require for large biomolecules. So understand your analyte, its molecular weight. Smaller pores, more surface area will give you higher retention. Larger pores, better accessibility for proteins and peptides. Correct pore size will give you optimum retention and improved resolution. So first is the column dimension, then is the particle size of your stationary phase, third one is the pore size. Then how you are going to select the stationary phase. So its chemistry required to be understood. Stationary phase chemistry defines selectivity and the retention. Common options: reverse phase C8, C18, phenyl, non-polar to moderately polar molecules, and normal phase polar analytes, HILIC, very polar compounds. Selection of the stationary phase must align with the analyte properties. Correct phase improves separation quality and the robustness. So what type of HPLC method you are developing, that will give you some information for the selection of stationary phase. Your Options may be normal page HPLC or RP HPLC. Application specific columns. So there are different columns like chiral columns, ion exchange column, affinity column, size exclusion columns. Some analytes require specialized columns. Chiral columns, enantiomeric separation. Ion exchange columns, charge molecules. That means ion exchange columns are used for separation and study of the charge molecules. Affinity column for biomolecular interactions. Size exclusion columns for molecular size separation. Then preparative columns are also there for the separation of the molecules. Select the column based on application needs to achieve the reliable reproducible results. Column quality and manufacturer's reputation. Evaluate batch to batch consistency. Ensure mechanical stability and longer column lifetime. Check for availability of application notes, technical report, performance certificates for selection of the column. High quality column ensure precision, reliability and reproducibility. Summary: selection of the right column. Right HPLC column is the foundation of successful separation. Consider dimensions, particle size and pore size, stationary phase chemistry, application requirements, manufacturer quality. Optimize column choice, higher resolution, robust method and long-term use and cost efficiency. Whenever you are going to choose the column, always correlate the method requirement, correlate the analyte, its chemistry, and what you are going to do with the column. So based on that, you can select the right column. If your column is itself wrong or it is not suitable for the method, then you cannot get the good results. So always have the knowledge about column selection. Thank you for watching the video.